All right, let's jump right in. If you've ever been stuck in dense city traffic, you know what that controlled chaos looks like. But today, we're going to zoom in on something you might not even notice: the tiny, crucial spaces between motorcycles, and how understanding that little gap could literally save thousands of lives. Take a look at this number. It's staggering. That's how many people riding motorized two-wheelers died on India's roads in 2022. Alone. That's over 200 people every single day. And here's the kicker: a huge number of these aren't the crashes you'd expect, like with cars or trucks.
That's right. The data shows that for more than 27,000 of those fatal incidents, both the person at fault and the victim were on motorcycles. It tells you something really chilling. Sometimes the most dangerous place for a rider is right next to another rider.
And this is the question that's at the heart of everything we're talking about today. What if we could shift from just reacting to these tragedies to actually getting ahead of them, using artificial intelligence to see that moment of danger before it even happens?
So to really understand the solution, we first have to appreciate the problem itself. Let's take a closer look at this unique and often really risky dance that motorcycles do in the middle of all that city traffic.
And if you want some perspective on just how big this is, motorcyclists made up almost half of all traffic deaths in India in 2022. I mean, their agility is what makes them great for getting around a city, but it's the very same thing that makes them incredibly vulnerable.
This quote from the research just nails it. It's not always about raw speed. It's about being unpredictable. This inconsistency is basically the scientific way of describing that zigzagging and weaving we've all seen. And it's that exact behavior that makes it so tough for anyone, even other riders, to guess what they're going to do next.
So how in the world do you even start to study something that seems so random? Well, you go straight to the source and you collect a massive amount of data. Let's see how these researchers managed to decode this complex weave.
So here's what they did. They set up a high-res camera right over a busy 6-lane road in Faridabad, India, and just recorded during peak hours. Get this. From only 1 hour of video, they pulled out almost 400,000 individual data points, tracking the exact movements of over 1,000 different motorcycle interactions.
The one key thing they were measuring was this: the lateral gap. The analogy here is perfect. Just think of it as a vehicle's personal space bubble. It's a really simple idea, but it's so important. The way that bubble shrinks and grows is a direct measure of how much risk is involved.
Now, this is where it gets really clever. They didn't just look at two bikes. They tracked the main motorcycle, the subject vehicle, and the one it was directly interacting with. But crucially, they also tracked any other influencing vehicles nearby. Because, as you know, a car changing lanes or a rickshaw up ahead can totally change the dynamic of that little dance.
Okay, so you've got all this incredible data. Now what do you do with it? Well, this is where the study sets up this amazing contest. A traditional statistics model goes head-to-head with modern machine learning, all to see which one could predict a rider's next move.
Think about it like this. The old-school method, GLR, is kind of like a detective looking for obvious clues. If A happens, then B must happen. Machine learning, though, that's like bringing in a whole team of forensic experts who can see hundreds of tiny hidden connections all at once. It learns the subtle patterns a person would just completely miss. And the results? Whoa. It was an absolute knockout. It wasn't even a fair fight. The traditional model scored a 0.65 for accuracy. That's fine, but look at the machine learning models. Random forest and gradient boosting hit 0.99. That is near perfect prediction. The AI could basically read the rider's intentions just by looking at the traffic around them. Okay, so we know the AI is basically a fortune teller for traffic gaps. But which gaps are the dangerous ones? The next logical step was to use this incredible predictive power to define the exact point where a normal, everyday interaction turns into a really high-risk situation. And here it is. The study was able to pinpoint it. The critical lateral gap is 0.63 meters. That's about 2 feet. Based on all that data, this is the magic number. Any closer than this, and you are officially in the danger zone.
So how does the AI actually figure this out? It uses something called a decision tree, which honestly works just like a simple flowchart. It just asks a series of yes or no questions about the traffic to see if the conditions are just right for one of those unsafe critical gaps to form.
So let's just walk through a real scenario using this tree. The model figured out that you're way more likely to get into that 2-foot danger zone if, number 1, there's a fast car or something to your left near the curb, number 2, you yourself are riding further out in the lane, And 3, the speed difference between you and everyone around you is pretty small. It's like a specific recipe for disaster that the AI learned to spot in an instant.
And this, right here, is where all that data and all that math becomes incredibly powerful. Because it's not just about predicting danger, it's about preventing it. This research gives us a clear blueprint for engineers and city planners to actually design safer roads. So the payoff is a set of really clear, actionable steps. First, if you're building a motorcycle lane, make sure it's wide enough for 2 bikes to travel side by side with more than that critical 0.63-meter gap. Second, use speed calming measures like lower speed limits, especially in those curb lanes. And third, use signs to actually reserve those curbside lanes for slower vehicles, like motorcycles, to physically separate them from faster traffic.
And let's be perfectly clear about this. These aren't just good ideas or vague suggestions. Every single one of these recommendations comes directly from analyzing almost 400,000 real-world moments on the road. They are strategies built on solid evidence.
And really, that's the question this research leaves us with, isn't it? We've seen what the technology can do. We can understand and predict risk with an accuracy that's almost unbelievable. The challenge now isn't with the data or the AI. The challenge is for us to take this knowledge and build it into the very roads we use every day, making our cities safer for everyone.